everyone. Today we're going to learn 16.1 and that's solving exponential equations. And the first thing we're going to do is take a look at the exponential equations graphically to see how we can obtain the solution graphically, and then we will get into solving using algebra. So let's take a look at the steps to solve exponential equations graphically. So these would be the steps that you take, and it should be familiar for all of you guys actually. We've been doing this quite a bit with the graphing calculators, so it's very typical that we set one side of the equation as one equation and then set the other one as a separate function and then graph them simultaneously on the same chart so we can see where the graph intersects, and that would be the solution. Now these would be the steps that you would go through for graphing calculators, but with decimals it's a lot simpler and you guys should know that. So I'm going to show you guys how to graph on the decimals, and here is the first question. Solve the equation graphically, and that is right here, the first equation. And to make this problem a little simpler, I'm going to divide both sides by 275, and so I should have e to the 0.06x equals 3.64. And we're going to let the left side equal to y1 and the right side equal to y2. Notice that I already have those two equations written here in this graph. And so the exponential is the red one and the linear equation is the blue one. And notice that I've already found the location where they would meet, which is right there. And so the x value that we are looking for is 21.5 approximately. So the answer to this problem is actually about 21.5. And so you can see that easily we can solve this problem graphically by just graphing the two simultaneously on the same graph. So go ahead and try this on the decimal. Pause the video and try it on decimal and make sure that you're getting the same answer as me. And then when you finish, go ahead and try the next one without looking at the answer, of course, on your own to see if you know how to do this, and then look at the answer. So hopefully you've had a chance to try the problem, and then let's take a look at the solution. I would actually, the first step, add 1 to both sides to make it a little cleaner, the equation. So I have e of x equals y1 equal e of x, and y2 is 65. Notice that I have already graphed those two on the same chart here, and also found where they would meet, which is right here. So the answer is actually x is approximately 4.17 where they would intersect. So that is the solution to this problem. And then next thing is, so we've already seen a couple of examples on how this is done graphically, but let's take a look at how else can we solve the logarithm or exponential functions, and that is using algebra. So one way is to rewrite them using logarithm form. Another way is to use the one-to-one properties that we have here and then to set them equal so you can solve. So remember, you can take logarithm of both sides of an exponential equation to get rid of, sort of like undoing the x squared by taking the square root of both sides. So that's what the exponential and logarithm functions do to each other. They are inverses of each other. And we can also use the other properties of logarithm to solve. So let's take a look at some examples here. First example, solve each equation algebraically. So it does not ask us to solve graphically anymore. It says use algebra. Give the exact solution and an approximate solution to 3 decimals. So let's keep that in mind, 3 decimal places. And so the first thing we're going to do is rewrite, because we want to get x by itself. So therefore we want to rewrite the equation with logarithm, because that is the way to undo the exponential. Right now the x is in the exponential form, so we got to use log to undo that. So we're going to take the log of both sides. Taking the log of both sides, we are going to bring the 2x, because it's a power. Remember, one of the properties of logarithm means the power can go in the front. So we got 2x log of 4 equals log of 6. And now we can actually divide log of 4 on both sides to get rid of that log of 4. So we have 2x equals log of 6 divided by log of 4. And finally, to get rid of that 2, I'm going to multiply both sides by 1/2. And that will cancel out the x. So I have x equals log of 6 over 2 times log of 4. And so if you actually just input that into the into a regular scientific calculator, you should have the answer 0.646, and that would be the final answer. And please go ahead and use your calculator to obtain the answer, to make sure that you are getting this answer. So this is like a test for your calculator to make sure you are on the same page. We're going to take a look at another problem here. We're going to do the same thing that we just did earlier and applying to the second problem. So the first thing again we're going to do is take the log of both sides. So we got log 8, and notice that this power right here can go in front. So we have 2x minus 5 times the log of 8 equals the log of 48. And the next thing I'm going to do is divide both sides by log 8. And that will get rid of the log 8. So we have 2x minus 5 equals log 48 over log of 8. And of course, the next thing we're going to do is add 5, just like we would usually do with an equation. And we have 2x equals that whole thing right here. And finally, the last thing that we are going to do is actually multiply by the 1/2. And then don't forget the plus 5 is in the back. And then multiply by 1/2 on both sides. We'll get rid of that 2. So finally, we would have x is equal to 1/2 of that whole thing on top. Now, if we actually just work it out in the calculator, we should have the answer of 3.431 as the final answer. So go ahead and practice getting that answer in your a regular calculator, and to make sure that we have the same answer. Moving on to the next problem, part C, we're going to practice some more with this new logarithm function that we have. And so we're going to start with taking the log of both sides as well. So there's actually, this problem is calling for another way to do the problem. So we can do the same way that we just did earlier, or we can actually try this problem in a different approach. And that is to actually realize that 27 can be written as the base of 3. So it's actually 3 to the third. And then we have 2x plus 1 as well. And so now, because the base are equal, we can say that the exponents are equal to each other. So we have 5 and we're going to distribute. So we have 6x plus 3, 5x. And then without using all the logarithms. So you can, of course, go and do the same approach as what we did earlier, or you can do it this way, which seems to be a lot more cleaner. And let's take a look at the next problem. And we're going to obviously cross out the 5 first. So we have 2x to the minus 1 equals 75. Next, we're going to divide it by 2. Remember, keep in focus that we want to get that x by itself. So we got to get rid of everything else. So e to the x minus 1 equals 37.5. And at this point, we're going to actually undo the base of e by taking the natural log of both sides, because natural log of e cancels out, and we have x minus 1 equals natural log of 37.5. And then finally, we're going to add 1 to both sides, and so we have x equals natural log of 37.5, and that is plus 1. And we're going to round off the answer to 3 decimals, so it's 4.62. It's 4.624, and that is the final answer. problems are for you to try it, so make sure you guys try it before you look up the solution. So hopefully you've had a chance to try it. Let's go ahead and practice. Notice that I cannot rewrite 6 or 12 using the base of anything. So I have no choice but to use the first method, which is taking the log. And maybe that's how you can distinguish. So we're taking the log of both sides and then bring the 3x in the front. So we got 3x here. And the next thing is dividing by the log of 6. And we have 3x is equal to log of 12 over log of 6. Finally, dividing by 3 or multiplying by 1/3 on both sides. That will give us x equals log of 12 over 3 log of 6. And then using your calculator to get the answer to 3 decimals, you should have 0.462 as your final answer. Part B, we are actually going to rewrite 81 and 243 as base, because I realized that 81 is 3 to the 4, and then we have x. And then 243 is actually 3 to the 5th, and then we have x plus 2 on the side. So because the base are equal, we can set up the exponents. 4x equals 5, and then distributing, we have 5x plus 10 minus 5x to both sides. I have negative x equals 10, and then therefore x equals negative 10 as your final exact answer. And part C, we got, again, I cannot rewrite 5 and 50 with any power, with any base to any power. So therefore, I'm just going to take, you can either take log or natural log, remember. Log and natural log are the same. And then this power becomes the front. So 5x minus 6 natural log of 5 equals natural log of 50. Divide natural log of 5 on both sides. And we have 5x minus 6 equals natural log of 50 over natural log of 5. Again, you can use log or natural log. Next, we're going to add 6. And then finally divide by 5, or just multiplying by 1/5. So we're going to have x equals, let's write it over here, equals 1/5 times that whole thing, natural log of 50 over natural log of 5 plus 6. Using your calculator to get the answer, you should have approximately 1.686, and that is the final answer for this problem. And the next slide will have a discussion. When solving an exponential equation with base e, what is the benefit of taking the natural log of both sides of the equation? So let's assume that you have natural log e of x equals 5. So what is the benefit of taking the natural log of both sides? Well, that is actually to undo the e base. So you will actually have x equals to the natural log of 5. So that would be the benefit, which is to undo the exponent, the base e. And that is a wrap for today. So your homework is, don't forget, you have book set 16.2, day 1. And that's page 637, number 1, 5, 6 through 11. And then don't forget you have HRW 16.2. And then don't forget to copy notes for 16.2, day 2. And then don't forget, finally, Alex. Have a good day.